Motion of variable mass system. Before going to discuss about motion of variable mass system, let us have a bird's view on Newton's laws. Newton's first law. Every body continues to be in its state of rest or uniform motion unless an external force acts on it to change the system. This property of the body is known as inertia, and Newton's first law is also called as law of inertia. In this slide we can see two pictures. One, a person hitting football, and the second picture shows that the football has been stopped once it has touched the net. Until a person kicks the football will be in rest position. It does not move by itself. When a person kicks the football, that means an external force is acting on it. As a result, it moves in a straight line motion until it touches the net, where the net applies force on the football. As a result, the football's straight line motion has been stopped by net. In this way, Newton's first law is explained from the two pictures given in this slide, where the football continues to be in its state of rest or in a straight line motion until an external force is acting on it to stop from straight line motion. This law is also known as law of inertia. This law is all about reference frames. A set of coordinate axes attached to a particular object relative to which motion of a body can be described is called as a reference frame. Newton's laws are valid only in inertial frames. The frame of reference attached to the earth is assumed to be inertial, whereas the earth rotates about an axis and also revolves in an orbital motion from the sun. But since all the experiments which we perform on the earth do not need any such accuracy, we assume that the earth is also an inertial frame of reference, whereas indeed it is not so. Newton's second law. It has been observed that the time rate of change of momentum of a particle is equal to the net force acting on the particle and takes place in the direction of force, which can be written in equation as F is equal to dP by dt. The figure given below explains Newton's second law, where the force acting on the bicycle results in the speed of the bicycle. If the person is applying more force, the bicycle will move fastly. If the person is applying less force, the bicycle will move with less velocity compared to the person who is applying more force. Newton's second law can also be written as external force acting on a body is always equal to product of mass of a body and its acceleration. This law is also called as equation of motion of a mass point. It can also be written in other words as time rate of change of momentum of a body is equal to the net force acting on the body and takes place in the direction of force. Newton's third law, which is a well-known law. To every action there is equal and opposite reaction. It can also be explained as every action force will have a reaction force, but the thing is the two forces act on two different bodies. This can be written in the figure as F12 is equal to minus F21. If we see the picture, we have two people applying force on each other, whereas the first person is applying force on second person, the second person is applying force on first person. It can be shown in the equation form as, for suppose m1 is the mass of the first person, m2 is the mass of the second person, then the force acted by first person is given by F21, second person is given by F12, where F21 is equal and opposite in direction, that is represented as F21 equal to minus F12. We have lot of examples where Newton's third law could be explained. For example, a person standing on the floor is also best to explain Newton's third law, where the person is applying all his weight on the floor and at the same time the floor is applying same amount of force on the person. As a result, there are two forces which could not be seen by our eyes: the force acting on the floor, the force acting on the person. In fact, these action and reaction forces are the main reasons for so many things happening in our daily life. Next comes motion of variable mass system. If the mass of a system changes with time, then it is known as variable mass system, which is an important concept in the case of motion of a rocket. Earlier classes we could have studied about mass remaining constant only, and such systems are also called as isolated systems. Whereas when we are studying the motion of a rocket, this does not fall into isolated systems, but it is a system of variable mass, where the mass of rocket in motion continuously decreases, and hence it could be understood only by understanding motion of variable mass system. In this figure, for suppose initially the mass of a given object is capital M, moving with constant velocity capital V. After a time interval of dt, dm mass is separated from the mass m, and this dm mass velocity is given by u. Or it could also be considered as there are two masses, one moving with velocity v and mass is m, the other mass dm moving with velocity u. Both are combined and their combined mass is given by m plus dm, velocity given by v plus dv. So, in these two cases, first case the mass decreases, second case the mass increases. When we consider a system where the mass is decreasing, then it can be described as a system of mass m whose center of mass is moving with velocity v at some instant of time t. After a small interval of delta t, at t plus delta t, a mass delta m has been ejected from the system and its velocity is u. The system mass is reduced by m minus delta m, thus moving with a velocity v plus delta v. From Newton's second law, we already know that external force acting on a system is always equal to rate of change of momentum, that can also be written as m minus delta m into v plus del v plus del m into u minus initial momentum mv divided by time interval delta t, where pi and pf are the final and initial momentums of the system. External force can be written as m into delta v by delta t minus v into delta m by delta t minus delta v into delta m by delta t plus u into delta m by delta t. If delta t approaches to 0, then the acceleration due to gravity is. Expression for variable mass system will go on as follows. External force is equal to m into dv by dt plus v into dm by dt minus u into dm by dt. Now the external force acting on the system is given by d by dt into mb minus u into dm by dt. The above equation can also be written as m dv by dt is equal to external force plus u minus v into dm by dt. The last term is the rate of change of momentum of the system due to mass having it and is called the thrust, which must be as large as possible. Therefore, m into dv by dt or ma is equal to external force acting on the system plus reaction force. Using this variable mass system concept, we could explain motion of rocket by assuming that the initial mass of the rocket is capital M, initial velocity is capital V, and after a time interval of dt, the mass decreases by dm and mass becomes m minus dm, velocity of the rocket becomes v plus dv, whereas the decreased mass travels in opposite direction and hence its velocity is written as u. So, using these variable mass system equations, we could understand the motion of a rocket and also we could derive equation for initial final velocity of a rocket, assuming initial velocity to be 0.